JavaScript array methods look simple, but they quietly decide how your code performs, mutates, and breaks. In this video, we are going to look at the most common JavaScript array methods. We will cover how they work, what they return, and when you should use each one. Map is an array method that transforms each element and returns a brand new array. It takes an existing array, applies a function to every item, and collects the results for you. When we use map, we pass a callback function to it. This callback decides how each element should be transformed. In this example, we start with an array containing the values 3, 2, and 1. As map runs, it takes the first element, sends it into the callback, and multiplies it by 2. The result, 6, is placed into a new array. Then map moves to the next element, repeats the same transformation, and stores the result again. This continues until every element has been processed, giving us a new array with the values 6, 4, and 2. So far, we've only used one parameter in the map callback, the element itself. But the callback can actually receive up to 3 arguments. The first one is the element, that's the current value being transformed. The second one is the index, which tells you the position of that element in the array. And the third one is the array itself, which gives you access to the original array if you need extra context. You can use just 1, 2, or all 3 depending on the logic you're writing. Before moving on, there are a few important things to remember about map. First, map does not mutate the original array. It always returns a new array with transform values. Second, map should be used for transformation, not for side effects like logging or API calls. If you're not using the returned array, map is probably the wrong tool. And finally, map does not wait for promises. If your callback is async, map will return an array of promises. Now let's look at one of the most powerful array methods in JavaScript, splice. Splice allows you to add, remove, or replace elements inside an array, all in one method. Let's start with this array, and then we are calling splice 1, 2, 3. The arguments mean 3 things: where to start, how many elements to delete, and what new element we want to insert. The first argument, start, is 1. That means the operation begins at index 1, which is the value 2. The second argument, delete count, is 2. So JavaScript removes 2 elements starting from index 1, in this case 2 and 5. The third argument is 3, which is the item we want to insert. JavaScript inserts this value exactly at the start position, index 1. So the final result becomes 7, 3, 8. Splice doesn't always have to remove elements. If the delete count is set to 0, nothing is deleted at all. This time we call splice 2, 0, 3. The start value is 2, so the insertion point is index 2. Because delete count is 0, JavaScript removes nothing. It just opens up space at that index. Then 3 is inserted exactly at index 2. Now that you've seen how splice works, let's look at the syntax. One thing to know is that if you only pass the start argument, splice will remove everything from that index to the end of the array. And splice isn't limited to inserting just one value. You can add multiple items at the same time by passing more arguments. Now let's look at the critical details. First, do not confuse splice with slice. The letter P in splice stands for permanent. Unlike slice, which just makes a copy, splice mutates the original array. Splice has a time complexity of O of n. If you insert or delete from the middle of a huge array, JavaScript has to shift every subsequent item to a new index. And finally, splice returns an array of removed elements, not the modified array itself. So if nothing is removed, it simply returns an empty array. Now let's look at the forEach method. ForEach executes a function once for every element in an array. When we use forEach, we pass a callback function to it. This callback tells JavaScript what code should run for each element in the array, and can receive up to 3 parameters: the current element, the index of that element, and the original array. You can use 1, 2, or all 3. We usually use forEach to run a function once for every item in an array to perform side effects like logging, updating the UI, or mutating external objects. It does not return a new array, so it's meant for doing something with each item, not transforming data. Now let's look at an example where we're simply logging each element one by one. We start with an array. When forEach runs, JavaScript takes the first element and passes it into the callback function. The code inside the callback runs, logs the value, then automatically moves to the next element. This continues one by one until every element in the array has been processed. There are a few things to keep in mind when using forEach. forEach always returns undefined. This means you cannot chain other methods after it. If you try to do this, your code will crash. Think of forEach as the end of the line. You use it to finish your logic, not to build more arrays. Second, forEach expects synchronous code. If you need to wait for asynchronous operations, use a standard for-of loop instead. And finally, unlike a traditional for loop, you cannot use the break or continue keyword inside forEach. The push method is one of the simplest and most commonly used array methods in JavaScript. As the name suggests, it pushes one or more new elements onto the very end of array. When we call push 6, the number 6 is appended to the tail of our array. You can even pass multiple arguments at once, like pushing 6 and 3 together, and they will be added to the end of the array in that exact order. One key advantage of push method is its efficiency, because adding to the end of array doesn't shift other indexes. We can use push in several forms. We can supply any number of items, and JavaScript will add all of them sequentially to the array's end. Push method mutates the original array, so be careful when working with arrays you don't want to modify. It supports adding multiple elements in a single call. And one detail that often surprises beginners, push method returns the new length of the array, not the modified array itself. The slice method creates a shallow copy of a selected range of array. It helps us extract parts of an array without changing the original one. When we call something like slice1, 3, it starts copying from index 1 up to index 3, but not including index 3 itself. So if our array is 3, 1, 7, 2, 5, the result would be 1 and 7. Now for another example, slice 0, -1. The first number, 0, is simple. It tells JavaScript to start copying from the very beginning of the array. But that second number, -1, is where the magic happens. In JavaScript, when you use a negative index, you stop counting from the left and start counting backward from the right. As you can see in the diagram below the array, -1 represents the very last item, -2 would be the second to last, and so on. So we're telling JavaScript to copy everything from index 0 up to the last index, but not include the last item itself. The important thing to notice is that the original array stays untouched, and a new copy is created from the selected range. Slice can be used in a few different ways. Slice with no argument copies entire array into a new one, and slice with only start argument begins at the given index and copies everything from there to the end. There are a few key things to remember about slice. Slice is a non-mutating method. Slice performs a shallow copy, so nested objects are shared between original array and the copy. And it's not limited to arrays. It also works on array-like objects that have a length and numeric keys. Now let's talk about the unshift method. Unshift adds one or more elements to the beginning of an array. You can think of it as the opposite of push. Instead of adding items to the end, unshift inserts them right at index 0. Suppose we start with this array, 7, 2, 5. When we call unshift 3, JavaScript takes the value 3 and places it at the very beginning. Unshift can also add multiple elements at once. Starting again with 7, 2, 5, if we call unshift 3, 1, both values are inserted at the front, and the order is preserved exactly as we pass them in. The syntax of unshift is very simple. You can call it with multiple elements, and unshift adds many values in one operation. There are a few important things you should remember about unshift method. First, it mutates the original array, so be careful if you're working with shared state. Second, it's usually slower than push, because every existing element must be reindexed to make room at the front. And finally, unshift returns the new length of the array, not the array itself. So if you log the return value, you'll see a number, not the updated list. Filter method selects items from an array based on a condition. Only the elements that pass the condition make it into the new array. Filter runs a function for every element in the array. This function is called a predicate function. It must return either true or false. If it returns true, the element is kept. If it returns false, the element is skipped. Let's walk through this example. We start with the array 36192. Each number enters the predicate function and gets checked if it's an even number or not. 3 fails the condition, it's skipped. 6 passes the condition, it's kept. 1 fails the condition, skipped. 9 fails the condition, skipped. 2 passes condition, kept. After the loop finishes, filter returns a new array containing only the matching values. So think of filter as a gate. Only values that pass the test get through. Just like map, the callback you pass the filter can receive more than one parameter. Besides the main value, it can also receive the index in the original array. These extra parameters are optional, and you only use them when your filtering logic needs more context. There are a few important things you need to remember about filter method. First, it does not mutate the original array. It always returns a new array. Predicate function doesn't have to return true or false. Any truthy or falsy value works, like 0 for false and 1 for true. And finally, filter performs a shallow copy. If the elements are objects, the references stay the same. The reduce method is often considered the most powerful array method in JavaScript. Reduce takes an array and continuously combines its items until only one final value remains. Let's look at how this works. Reduce requires 2 main arguments. First, a callback function, often called the reducer, and second, an initial value. The initial value is where the accumulation starts, and it defines the type of the final result, whether that's a number, an object, or a new array. The reducer is where the real logic lives. It runs once for every item in the array and receives 2 values, accumulator and current. Accumulator is your running memory. It holds the result returned from the previous step. Current is the item currently being processed. The magic happens in how you combine these two. Whatever you return becomes the new accumulator for the next step. This flexibility allows you to do almost anything. You can return a simple math operation to calculate the sum of numbers in an array. You can change the operator, and you instantly get a total product of numbers. Or you can get complex. By treating the accumulator as an array, you can track a running total history rather than just a final number. To see how reduce actually works, let's walk through an example of sum. We start with an initial value of 0. This becomes the first accumulator. Then reduce begins iterating through the array, passing the accumulator and the current item into the reducer function. On the first step, the accumulator is the initial value 0, and the current value is first element 3. So the sum of accumulator and current is 3. That return value becomes the accumulator for the next step, and current moves forward to the second element, value 1. So the sum becomes 4. In the next step, current is 5, and sum becomes 9. And in the final step, the current is 2. So the final accumulator is 11. This is the return value of reduce. Now that we understand the concept, let's take a look at how it's written in actual code. In 90% of cases, you will use the standard form we just discussed, passing a callback with just the accumulator and the current element. However, for more complex logic, the reducer function actually accepts 2 additional optional parameters: the current index and the original array itself. You can include the index to track position and the array to reference the original list while you are reducing. To wrap up, here are 3 golden rules to keep in mind when using reduce. Reduce does not mutate original array. Initial value parameter is optional, but make it a habit to always provide an initial value. Providing an initial value makes reduce predictable and prevents errors when the array is empty. And finally, with reduce, you can filter items and transform them in a single pass, which is much faster on large datasets. The pop method removes the last element from an array. Let's say we have an array with the values 7, 2, and 5. When we call pop on this array, JavaScript removes the last item, which is 5. So we get 2 results. First, the original array is modified, and second, the removed value is returned. Now let's go over a few important notes. First, pop mutates the original array. It does not create a new one. Second, it's very efficient. Because it removes an element from the end of the array, it runs in constant time. And finally, calling pop on an empty array does not throw an error, it simply returns undefined. Next up is the shift method. While pop removes items from the end of an array, shift is used when you need to remove the very first element. Let's look at how this works. We start with an array of 3 numbers, 7, 2, and 5. When we call shift, JavaScript removes the first element from the array and returns that removed item, not the array itself. The original array is modified, and every remaining element shift 1 index to the left. Now, before you use shift everywhere, there are 3 important things you need to know. First, shift method mutates the array. Unlike map or filter, this permanently changes your original data. Second, be careful with very large arrays. Because you are removing the first item, JavaScript has to shift every remaining item over by 1 to fill the gap. This reindexing makes shift significantly slower than pop for massive datasets. However, it is extremely useful for queue logic. The first item in queue is the first one to leave. That's it for this video. I hope it clarified how array methods works, and I'll see you in the next videos.